Hello everyone, and welcome to another programming and ARM assembly video series that I'm going to be doing here. And in this video I'm going to create an ASCII to integer converting function. I did something similar to this in the number guessing game, but I wanted to rebuild it because I can do a bit better with that function, and I wanted to make it just kind of its own video. That way I can build up kind of a utility chest playlist of videos. Alright, so let's go ahead and take a look at what we have here. So as always, I'm starting with a mostly empty directory, but we have a couple of things in here. We have the print.s utility that I've built in a previous video, so if you haven't seen that video, you might want to go ahead and check that out. I don't want to rebuild everything every time, so I'm going to be utilizing that print.s function that I've already made. And of course, I like to start with the make file. I'm not the greatest at getting the syntax, so I like to just build it up ahead of time. And what we're going to have here is our main file. That's just going to be the driver code for the new function that I'm going to create called a2i.s. And again, we have that print.s that I've already built, and I've already got a video on that. So we're going to be assembling these three files, passing in the -g flag in case I need to look at things in the debugger. Then we're going to link everything together, and as always, once the linking is done, I'm going to remove all the .o files so that when I type make again, it will rebuild everything. Okay, so let's go ahead and jump into some code here. So we'll start off with the main.s file, and in this main.s file, I'm going to need a .global directive that points to the entry point into the code, which by default is _start. You can change that if you want, but I don't feel the need, so I'm not going to. Start label is going to go here. I'm going to need a place where I can exit out of the code, so I'm going to put that label there. And for now, I'm just going to move into register 0 the immediate value 0, and we're going to move into register 7 the immediate value 1, and I'm going to do a service call to 0, and then I'm going to put in the .in directive. So this is what's required to have kind of a bare minimum file for assembling, linking, and being able to exit out of the program without having it hang. And then I'm going to create the a2i.s file, and we'll have a .global directive at the top. We'll have a2i as the name of our function. We'll have the a2i label here. And again, we'll have at some point we'll have an exit label to get out, and then the .in directive. So I'm going to go ahead and save that, and that should be everything that I need in order to make the make file happy and be able to assemble and link. So let's give that a try. Let's make, and let's run and make sure we can see our exit code. All right, we've got that. Okay, so this is actually my second time recording this video, so I'm going to take what I've already learned and leverage that so that things will be a bit more efficient. So let me show you this document that I've got over here. So first of all, I've always got this system call reference available to me because, so often we need to be able to read and write and sometimes open and close files. So I always have that available to me. And what I've done is I've just taken the common ones and I put them down here in a format that I can mostly just copy paste essentially straight out of here. Sometimes when I look at the way that this is documented, I have to really think about what they're talking about, but when I look at what I've got down here, it's much more clear. And then I've got a little section here just as a sort of a cheat sheet for reading user input, so I'll be glancing at that pretty soon. And then we've got our ASCII table, and then I have here basically the outline of what I want to accomplish with this new ASCII to integer function. So let's walk through this outline. It's pretty easy. So as always, we're going to have some kind of input and potentially some kind of output. And I'm saying that my input must come from register 1, and that the value essentially in register 1 has to be a memory address of our string. So in other words, when we call this a2i function, the a2i function won't work unless this condition's met. So the R1 must contain the memory address of our string, and our string, of course, is going to be a number. But it's going to be ASCII characters. It's not going to be an integer. So it's going to be like, quote, 456, unquote, something like that. And then I'm saying that when we're done with our processing, our output is going to be that R1 will contain the converted value. So when we take the input, R1 is going to contain a memory address, and the output is going to be an integer. So the process that we need to go through here, number one, when we enter into the A to I function, we're going to save and initialize registers. So we need to push the registers that we're going to be working with onto the stack, and then when we exit, we need to pop those back off the stack. So because we want this to be general purpose, we don't want to make any assumptions about what might be in the registers other than R1. So we want to preserve whatever values there are, and then pop those values back out when we leave. And then we're going to do some, we're going to initialize these registers. These particular values don't necessarily have to be the way they are, but for example, we're going to initialize register 2 with the immediate value of 0. And this register 2 is going to hold the ASCII to integer conversion while we're working on it. And then we're going to move into register 3, the immediate value of 10. And that's just because when we do certain instructions in ARM assembly, we can't use immediate values. They have to come from a register. So I'm just choosing, for example, register 3 will hold that power of 10, so that when we need to do a multiplication operation, we have that immediate value available to us. And then I'm going to use R4 or some register. Again, it doesn't have to be R4, but I'm going to use a register to hold a value, essentially a Boolean value of either true or false. When we enter into the program, we're going to initialize this. We're going to initialize register 4 as +1, and so this is basically going to be a positive or negative multiplier, because if the person enters in like -456, I want to be able to handle that negative case. So once we initialize the registers, one of the first things we're going to drop into is determining, is the value negative or not? And the way we can determine that is simply by grabbing the first byte off of the string and asking, was that first byte the negative sign? And if it was, we're going to update this register here with the value -1, and then we'll come back to why we're doing that later. But if they did not, if the first byte that they entered was not negative, then what we're actually going to do is back up the pointer by 1, because let's say that they entered 456. We read the first byte, we see that it's a 4, so that 4 is not the negative sign. So before we drop into the loop, I want to back the pointer back up by 1 so that it's still pointing at 4 and not pointing at 5 in the case of like 456. So then we drop into our loop, and then we're going to grab the next byte of the string, whatever the next byte happens to be. And this is again why we need to back up that pointer if it was not a negative sign. So we're pointing to the first value. So in the case of 456, we grab the value 4. I should say the ASCII value, which is the character 4. And then the next thing we need to do is we need to remember that when we look at our ASCII table, the number 4 isn't actually the number 4 inside of the computer. It's actually, in terms of the decimal value, it's the number 52. In terms of its hex value, it's 34, and then we've got the octal value as well. But I'm more comfortable thinking in terms of decimal, so I'll refer mostly to the decimal value. But again, if we have that number 4, we need to subtract 48 from it, because we're actually, when we read the value 4 out of that string, the actual representation is the number 52. So we're going to take that number 52, we're going to subtract 48 from it, so that we actually have the integer 4. And then once we've done that, we want to determine, was the result of that subtraction a negative number? In the case of like reading any number, 4, 5, 6, 1, 2, 3, all the way up, all the numbers, that will never be yes. But when we get to the end of our string and we're reading either the carriage return or a null byte, when we do that subtraction, we're going to find that we ended up with a negative number. So if we hit a negative number, we're done. We have determined that we've hit the end of our string essentially. So we're done. We want to exit out of that loop. If that's not the case, if it's not negative, then we want to do this multiplication operation where we're going to take whatever register that we're using to hold our value, which I've determined up here was going to be register 2. And we need to say that register 2 is equal to the power of 10 multiplier times register 2 plus the new value that we just read. So the first time we go through the operation, like in the case of 456, R2 is going to be 0. So 10 times 0 is going to be 0. And then 0 plus 4 is going to be 4. And then the next time we go through the loop, in the case of 456, we're going to read a 5. And now we're going to say R2 is going to be equal to 10 times 4, which is 40, plus 5. So that number is going to be 45. And then the next time we go through the loop, we're going to be saying that R2 is equal to 10 times 45, which is 450, plus the new value, which is 6, which is 456. And then the next time we go through the loop, we will encounter the carriage return. And when we do the subtraction, it's going to end up with a negative result. And then when we get that negative result, we're going to jump down to this label. I'll probably actually end up calling this something else. But essentially, we want to update, or we want to determine if the number was negative. We're going to multiply the result that we determined from our loop times that times register 4, which is the register that holds that positive negative multiplier. When we enter into the program, we're going to assume positive. But if they did type in that negative, the dash or the hyphen, we will have updated R4 to -1. So at this point, if the number that they typed in was negative, we're just simply taking like 456, we're multiplying it by -1 so that it will come back out as negative 456. And then once we've done that, we're going to keep our promise, and we're going to set R1 equal to whatever value we determined, which, in this case is coming from register 2, because according to our input-output, we're saying that when we're done, R1 will contain the converted value. So that's what we're doing here. We're just keeping that promise. And then finally, we fall into the exit where we pop the registers off the stack, and we branch exchange back to the calling program. So that's the idea of what we're going to do. And again, since I've already recorded this, I've already kind of gone through all these steps. But in a sense, that's good, because now it gives me a roadmap to follow. Okay, so let's go ahead and end video number 1 right here. And when we come back in the next part, we'll jump into we'll go ahead and jump in to the code and get all of this put together. Hopefully we can get it done in the next video. If you made it all the way to the end, thank you so much for watching, and I hope to see you in the next part.